good morning. I am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with the next topic of the subject, that is wireless and mobile communication, and the topic of today's lecture is CDMA, that is code division multiple access. So, in this lecture we will going to discuss about the basics of CDMA, then different channels. There are two types of channels associated with CDMA. First one is forward channel and second one is the reverse channel. So, first we will discuss what is CDMA. So, CDMA is a kind of multiple access technique, and its full form is code division multiple access. So, all of you aware of multiplexing technique like TDMA, CDMA, TDM, FDM or TDM, FDM, where the specified time slot or is given to each user in which they are allowed to access the common channel which has been shared by different users. So, this is the concept in multiplexing, where this is a channel and let us say there are 3 users which are associated with this particular type of communication, and these these has to access this common channel. Now, how it is possible? It is based either on TDM, where this the available time of the transmission is divided equally among these number of users. Another one is FDM, that is frequency division multiplexing, where the whole frequency band is equally divided among n number of users. So, that is the case for multiplexing. But in case of multiple access means when you want to access any device and that device has to be shared between n number of users. So, that is the multiple access technique. So, that is first one is TDMA, FDMA, and next one is the CDMA, that is code division multiple access. So, it is a kind of fully digital wireless data transmission system, which means that no analog type of information is being sent, but if you know that the original information is in the form of analog only. So, at the transmitter side, to convert it into digital, we require an ADC, that is analog to digital conversion is required. So, the different steps that are involved in ADC is, first one is sampling, then quantization and encoding. So, that is a kind of digital process. Now, once the signal is converted into digital, it can be transferred over this channel, because there are several advantages of digital signal as compared to the analog signal. Now, this CDMA is not designed for voice at all, means it is just if you want to download something on internet or from internet or to upload. So, for internet access, to provide the internet access to the user, this CDMA technique has been designed. Now, it uses special random numbers to encode bits into information. So, basically behind this CDMA, what is the basic concept? It require Walsh codes. So, Walsh codes are required. Now, these Walsh codes belongs to a table that is known as Walsh table or Walsh matrix, you can say. It is a kind of 2 cross 2 matrix, and in case of this 2 cross 2 matrix, the variables are like this one. So, that is the Walsh table. So, here it is a 2 cross 2 matrix, where you can see these elements are 1 and this one be minus 1. So, let us say I have a 2 bit of code that I want to transmit, let us say it will be 1 and 0, then it will be matrix multiplied by these elements, and then this will be the output, will be the Walsh code. Now, next is it allows multiple access by assigning different user different random numbers on the same channel. So, let us say 3 to 4 different let us say 4 users are there which are associated with this particular channel. Now, to each of the channel there is code C1, code C2 and code C3, code C4 are there. Now, how these codes will be generated? By using a 4 cross 4 table. So, in case of 4 cross 4 table, these will be the elements. So, these will be the elements of a 4x4 table. So, you can see in this particular diagram. Now, the only ability, only limit to the system is the computing of the base station and its ability to separate the noise from the actual data. So, this is basically the limitation of CDMA, and it is based on this particular kind of technique, that is Shannon theorem. Now, next one is the CDMA is a kind of access method. It is an access method, that is multiple access technique, and it is also known as IS-95. Then IS-95 was the first operating system to use this CDMA. So, another name for CDMA which is used is known as IS-95. It is invented by Qualcomm. Then it begins its production in the year, that is 1995. Now, at this point, this is still called 2G wireless, and it is known as a narrowband system. Now, being supplanted by CDMA 2000 or WCDMA. Now, there are two types of CDMA which exist. First one is narrowband CDMA, other one is the wideband CDMA. In case of this wideband CDMA, it is known as CDMA 2000. Why? Because it is invented in the year 2000 and it is having the higher frequency band, and number of users associated with this is quite large. It will cover the larger area. So, that is why it is known as WCDMA, and this IS-95, it is supplanted by UMTS also. It is fully 3G system. So, GSM till GSM it was second generation, and with the increase number of users and the requirement which has been increasing day by day, it is been associated with third generation. Now, they both use CDMA and it is known as wideband system. Now, next question arises that how this IS-95 or CDMA will work. Now, this operates in the same bandwidth as this GSM will work. So, there are two, since it is a kind of full duplex communication, so two frequency ranges are required. First is for forward channel, another is for reverse channel. So, this is for forward channel, this is for reverse channel. So, in case of this forward channel, when the data is transmitted from mobile to base station, then it has been transmitted for 1850 to 1910 megahertz. In case of base station to mobile, when the data has to be transmitted, it is from base station to mobile, and the frequency range which is it is using, it is 1930 to 1990 megahertz. So, this is the range of the frequency band in which the data has to be transmitted, and the center frequency is known as the cutoff frequency. Now, the channels are 1.25 megahertz. So, this is basically the guard band, you can say, which has been associated with each user. So, after the actual data has been transmitted, then an additional band is required as a guard band. Then 3.75 megahertz in CDMA 2000, 5 megahertz in UMTS is there. It results in approximately only 48 forward or reverse channel in pairs in IS-95. Then next is adjacent cell phone towers use the exact same channel as all the tower. So, that this is a major difference between GSM and CDMA. Since in case of GSM there is a problem of adjacent channel interference or co-channel interference. In that particular case, in adjacent channel and co-channel, there is a formula associated with this, that is n is equals to I square plus j square plus ij. Now, what this will decide? This will decide the cluster size, and it will also decide the two co-channel cells which are using the common kind of common set of frequency range. So, that is the case of adjacent channel or co-channel cell. So, in this case it is possible in CDMA that these are using the same set of frequency range, and it allows for much better frequency reuse and makes setting up a cellular network much easier. Next one is when a phone is turned on, it scans one of the forward channel to find a base station identifier. So this is the process that how this actually works. So whenever a phone is being turned on, and it will going to, the antenna will going to see that which forward channel or which frequency is having the strongest uh, it will identify strongest signal. Then it will going to start transferring the data comes on the strongest signal. Then the phone will sends out an encrypted pass key and gains access to the network. So there is an encryption key is there, which is a part of which is required from the security point of view, and this key is nothing but the PN sequence. Now this PN sequence is generally being known to the transmitter and as well as the receiver. Once it will match, then only the receiver will going to going to find out what the actual data it has transmitted. Now it can then send and receive the call. It is assigned a 1.25 megahertz wide frequency to operate on. Then it listens for pages on the forward channel to let in know it has a call incoming. Then this is all very similar to how GSM operates so far. So basically what it says that 1.2 megahertz of the frequency range is associated with every user, and that will act as a guard band to just separate the data of two different users. And also it listens for the pages on forward channel to let it know that it has all the incoming signals which has been coming in its way. And this is very similar to how the GSM will operate so far. So that is the basic idea behind this IS-95 working. Now next we will move to different types of channel. Like I have said that there are two different channels are there. First one is the forward channel, another one is the reverse channel. Now forward channel is from mobile to base station, and its frequency range is from 869 to 894 megahertz, and each channel is 1.25 megahertz wide. Next, it is divided into four different types of sub channels. Now first one is the pilot, second one is sync, then paging and traffic. Now each of the channels, since we are having four different sub channels, different in each of the channel there are four basically different types of sub channels are there. Like first one is the pilot. Now pilot is responsible for carrying the information of timing, then phase reference for coherent demodulation, and it is a means for signal strength comparison. So this is the case for pilot. Like pilot is a kind of sub channel. Next is the sync. Sync is another kind of sub channel. Now its work is to broadcast the future state of the long code register. Now what is the use, what is this long code register? Now this is nothing, it is the PN sequence which is generated by a PN sequence generator. Since its length is quite large as compared to the original data, so it is known as PN sequence generator. So it is been stored in a register that is known as long code register. So sync is basically used to provide the synchronization between the transmitter and receiver, so that both are having the same number of bits. Third one is paging. So it is used for call control information which has been transmitted. Last one is the traffic. So that is another sub channel. Now the use of this traffic is basically used for transferring the actual voice data. So that is the case for traffic sub channel. Now this is the whole diagram of forward link connection, forward channel. Now you can see from this particular diagram, it has been started from here. The first one is the output data rate. Now there are four different options of the output data rate which is being expressed in terms of bits per second. It can be 9600 bps, 4800 bits per second, then 2400 bits per second and 1200 bits per second. So this is the output of the audio compressor. So, there are different types of data rates which are available. Now, this particular output is given to the convolution encoder. So, there are two different parameters associated with convolutional encoder. First one is the size of the bits which you want to transmit. Second one is the rate of convolution. So, it is denoted by 1 upon 2. So, what we have taken is half for this. So, this is the standard diagram. Next, the output of this convolutional encoder will be 19.2 kbps. Then it is applied to a block interleaver. Now, this is nothing, it is a kind of an matrix which is of 24 cross 16. So, 24 rows and 16 columns are there. So, actual number of bits which is associated with this block interleaver will be 384 bits. Now, it is applied to a this modulo 2 adder. Now, what is the operation of this modulo 2 adder? It is performing the XOR operation. Now, XOR operation, as you all know, that if the input bits are different, then it is providing output as high, and when the number of inputs are same, then it is providing low output. So, that is the main concept of XOR which is used in this modulo 2 addition. Along with this actual data which you want to transmit using this CDMA in forward channel, a PN sequence is required that I was talking about, and it is being generated using a long code generator. Now, this is the block which is going to generate a 14 bit maximum length shift register. So, this is the maximum size of the bits which we can consider, but it can be restricted to 10 bits also, depending upon the number of bits, but it is for sure that these should have the larger number of bits as compared to the input bits. Now, this has been applied to a decimator. Now, the work of this decimator is to reduce the number of bits in between the actual sample points. Now, the output of this will be 19.2 kbps. Now, this will be data scrambled with this the input bit, and then there is a mux is required. After this, there is a Walsh code generator. So, basically after this PN sequence and this one, a coding is been required which is generated by Walsh table, and it is indirectly generated by Walsh code generator. Now, since it is a kind of Q channel and I channel concept, so there the actual data is divided into two different types of channels. This one will be the I channel, that is in phase channel, and this will be the quadrature phase channel. So, in this case I channel pilot PN sequence will be there. So, the output will be this one, and in this case Q channel the output will be this one. This will be XORed together, and then this will be the output, that is data to I channel of QPSK, and this is data to Q channel of QPSK RF modulator. So, this is the main concept of forward link. Now, we will going to discuss some of the blocks in detail. The first one is the convolutional encoder and repetition. Now, you can see that this adds the redundancy to data transmission for error or robustness, and its rate will be half, which we have taken over here, and where R is the number of input bits upon output bits. So, number of R is basically the rate, which is the ratio of a number of input bits divided by the number of output bits. Now, it maintains an output data rate of 19.2 kbps regardless of the input rate basically. So, this is the incoming data rate, as you can see in the previous slide also what I have shown over here, that the output of the audio compressor will be one of these data rate. So, what we have taken, we have to select only one between them, then it will be applied to a register which is of 9 bit register. So, this is a 9 element shift register. Now, you can see that there are two XOR gates are required to generate these two terms, that is G0 and G1, and the these values will be XOR together. Then note, while this is easy to implement at the transmitter, it is non-trivial to undo at the receiver. So, whatever concept we have used at the transmitter side, it has been untrivial at the receiver side also. So, you have to consider it with much more sincerity. Next block which has been described is the block interleaver, and I have told you that it is a kind of matrix only, where 24 number of rows and 16 number of columns are there, and at the crossing of each of the point like this one, these are basically nothing, these are having 384 number of bits. So, it separates when consecutive data bits are sent, therefore, adding to transmission robustness. It provides time diversity. Two pages are there, one is being filled as one is being emptied. Then each page contains all the data for 120 millisecond frame. So, it is 24 into 16 bits. So, total number of bits will be 384 bits. Now, when it is multiplied, so 19.2 kbps is multiplied by 20 millisecond per frame. So, total number of bits will be 384. So, data is read in as rows and out as column. So, this is the reading, and this will be the out, means you can say it will be input and out will be like this one. So, this is the use of block interleaver. Next one is the long PN sequence and scrambler. So, long PN sequence is basically the length which has been considered is 42 bit of maximum length shift register. It corresponds to 2 to the power 42 minus 1 possible permutations are there. Contents of the shift register are XORed with a public or private key depending on the stage of the call to generate one output bit at a rate of 1.22 MCPS, and it takes a very long time to repeat. So, basically this is the case for long PN sequence. Next one is the scrambler. Now, the work of this scrambler is used for data encryption. It make call more secure. It randomizes the data. It prevents the transition of a long series of ones or zeros. So, that is the use of scrambler. Next one is the power control bit. Now, work of this power control bit, it is dynamic, it is decentralized, closed loop power control scheme is there. A control scheme is basically a base station decides what to do based on the measured frame error rate. Then this frame error rate, when it is less than the threshold, then it decreases the mobile power by 1 dB, and when the frame error rate is greater than threshold, then it will going to increase the mobile power by 1 dB. So, that is the main concept of frame error rate. So, this is the theory behind power control. Next one is the orthogonal covering via Walsh code. So, 64 orthogonal channels for all the users, assuming negligible multipath delays are there. It provides some spreading. Spreading is basically when you are going to transmit this particular data, and when they travel over the channel, then spreading of the pulses will be there. So, that is the main concept of spreading. Next one is quadrature modulation. Now comes the reverse link. Now, reverse is basically when the data has been transmitted from base station to mobile phone. Now, same frequency range will vary from 824 to 849 megahertz. Then its access channel is 4800 bits per second. It initiate communication. It responds to paging channel message. Now, reverse voice traffic channel will be 9600 bps, then 4800 bps, 2400 and 1200. It is very similar to forward link, but there are important differences between forward and reverse channel are there. So, this is the main block diagram which is associated with reverse channel. Now, you can see again that this is a audio compressor which will going to produce the data of having these number of different data rates are there, like 9600 bits per second, 4800, and these are the different output data rates are there. It is applied to a convolutional encoder. So, in this case of convolutional encoder, this will be the output, where this is the number of input bits divided by number of output bits. Now it is applied to a block interleaver, so it is having 576 bits. Then it is applied to voltage code generator. So this is a 64 array orthogonal modulator that is codes 6 bits. Then it is applied to a data burst randomizer. Then this is a long code PN generator, and its output will be this one. So this is applied to a data scrambler device. Now there are two types of channel, like first one is the I channel, this one is the Q channel, and this is applied to these two different types of scrambling device, and this is nothing but a decimator which is been used over here. So this is a kind of reverse channel block diagram. So this is the explanation of reverse channel. Like first one is the orthogonal modulation. So it is a 64 array orthogonal modulation using the same Walsh function in the forward link. Then contrary to the forward link, it is used for orthogonal data modulation. Then modulated symbol rate, that is 28.8 kbps into 64 chips divided by 6 coded bits. So basically these are the number of coded bits which are being present over here, and it increase the interference tolerance. Next one is the data burst randomizer. So it turns off the transmitter when the data rate falls below 9.6 kbps, so that each of the redundant bit is sent only once. It is used to reduce interference to other users. Each 20 millisecond of frame is divided into 16 1.25 millisecond of slot, which are selected as a function of the long PN code. So this is the case for this was the case for data burst randomizer. Next one is a comparison between IS-95 and other second generation. So IS-95 is known as CDMA, and IS-54 or 136 it is known as GSM. So in case of GSM, it uses TDMA or FDMA frame, and IS-95 it generally uses the CDMA technique. Next, this uses hard handoff, this uses soft handoff. Now what is handoff? Whenever a transmitter or receiver mobile phone is moving from one cell to another cell, then what it requires the transferring of control signals from one base station to another base station, that is known as handoff situation. So there are two types of handoff. First one is hard and another one is soft handoff. Next one, it is an open loop and slow power control technique. It is closed loop and fast power control technique. This is a fixed rate vocoder, and this is a variable rate vocoder which is required for highest GSM as well as for CDMA. Now next is possible improvements of on IS-95. Like first one is increasing the channel bandwidth beyond 1.25 megahertz. First, this is an improvement which has been required. Next is directional antennas or mobile stations can be used, because in case of directional antenna the gain is quite high as compared to the omnidirectional antennas. Next is it is using the MANET technology, that is the mobile ad hoc network. Whenever a network is being set up, then it is being not permanent, it is temporary in nature. Last one is the adaptive filtering. So filtering which is being done, it is adaptive in nature, means it will going to change. So these are the references that you can consider for this particular topic. Thank you.